Hi guys, Buildzoid here from Actually Hardcore Overclocking, and today we're going to be taking a look at the TRX Aorus Xtreme from Gigabyte, and this is a very big motherboard. So, normal ATX boards end here. EATX boards end here, so they're wider, and that causes, potential case compatibility issues if your motherboard tray is recessed. And then right angle 24 pins make those compatibility issues worse because that 24 pin connector sticks out to off the where I can draw. So off the canvas here, and so that's already like, okay, that's something to watch out for when choosing cases for EATX boards. But no, this board was just not big enough to fit all of the stuff that Gigabyte wanted to fit on it, so they also made it taller.
Before that, this video is brought to you by the Be Quiet Dark Rock Slim, keeping a high performance focus but reducing the footprints to accommodate full memory slot compatibility. The Dark Rock Slim comes with one of Be Quiet's Silent Winds 3 120mm fans, built for low noise operation. The Dark Rock Slim advertises cooling capability up to 180 watt TDP, but mixes in a matte blackout color design to combine performance and looks. Learn more at the link in the description below.
So this thing is an XL-ATX motherboard, and that means that if you want to stick this in a case, your case better have at least 8 PCIe slots on the back, because otherwise this thing is literally not going to fit. Now, the obvious advantages to this board being absolutely massive is that it has allowed Gigabyte to cram a lot of stuff on it. So for one thing, you have all of these M.2 slots. So those are 3 110mm slots, and then I think it's millimeters, right? Whatever, they're 110 M.2 slots. And then you have an 80 M.2 slot over here, which I think you could actually, like, these seem to be aligned, so you could probably move, like, you could make this a 110 if you make that an 80. Not like I assume it doesn't really matter, but there's a lot of M.2 on this board, and it's full length, and it has a lot of length to it, so you can fit a lot of M.2 drives just on the board itself. Now, the other advantage is, of course, you get proper quad GPU spacing. Now, admittedly, quad SLI, quad Crossfire are both completely dead, but well, hey, if you're still benchmarking, TimeSpy or something, quad 1080 Ti's are kind of the way to do it. But the thing is, if you, like, outside of that, quad GPU setups are completely dead. So the main use for having this arrangement of PCIe slots is that you could run like quad Quadros or quad Titans if you're using them for rendering acceleration. You're restricted to dual slot GPUs if you actually want to use this slot and this slot, because yeah, like the layout doesn't support it any other way. Now, hey, that's not really, like, I wouldn't say that's the worst issue to have, but you might be well, I guess maybe with 2080 Ti's that kind of forces you into water cooling, I guess, because getting, well, high-end GPUs that pull a lot of power are just kind of difficult to cool in 2-slot form factors unless you go with water cooling, in which case, it's just kind of stops being an issue. The other thing that Gigabyte has crammed onto this board is dual 10 gig LAN from Intel. This right here is an ELX 550 LAN controller from Intel, and yeah, that's dual 10 gigabit hooks. Like, the ports are on this stack right here. And this is pretty much server grade LAN. You can't get it on, well, I'm not, Gigabyte has another motherboard that has this, but I'm not aware of any other board vendors offering motherboards with integrated Intel dual 10 gig. So that's also potential, like, that's potentially really, really cool for some people who, want that kind of networking support. Other than that, you also got M.2 Wi-Fi. Well, you've got a Wi-Fi card that goes right here. Anyway, we got a bunch of USB ports next to that. Then we've also got some rear I/O buttons. So you've got a clear CMOS button on the rear I/O, and you've also got a manual, like a Q-Flash Plus button, so you can update the BIOS of the motherboard without even having a CPU installed. Q-Flash Plus also, once, like, in theory, should automatically recover from corrupted BIOSes. But if you just have a USB stick with the correct file name plugged into the correct USB port, but my experience with automatic BIOS everything systems is that they suck. Speaking of automatic BIOS systems, this board has dual BIOS, which on Gigabyte boards is automatic. And you've got two LEDs to indicate which BIOS chip is currently active, so main BIOS, backup BIOS. I'm really not a fan of them being right next to each other like that, because you're not going to be able to tell which one is lighting up. In my opinion, they like these two LEDs should try to be as far apart from each other as possible, so that you can glance at them and get an idea of like, hey, it's a different area of the motherboard that's lighting up, not the exact same spot with the same color, because these aren't color coded, they're both orange. Anyway, yeah, so Gigabyte has an automatic dual BIOS system that basically, if you fail to post enough times in a row, it'll kick in and throw you onto the other BIOS chip. Now, the reason why this gets annoying is that your BIOS profiles are per BIOS chip. So if it switches BIOS chips, you lose, well, you don't lose them, but you can't access all of your BIOS profiles that you saved on the other BIOS chip. So to get around that, Gigabyte includes these two switches right here. So one of these switches puts the motherboard, and that's this one, puts the motherboard into single BIOS mode. So that automatic, you know, switching between the two BIOS chips, yeah, that stops happening because even Gigabyte acknowledges that it's freaking stupid, and I don't know why they haven't removed it yet. But next to that, you also get a BIOS switch that actually just allows you to select manually which of the two BIOS chips you're on. And, you know, like if you're in single BIOS mode and you maybe want to test out a new AGESA update or just a new update of the BIOS, you can go onto your like whichever BIOS chip you're not using as your main one. You don't necessarily have to you don't have to use the one labeled main as the main one. So you can go to your secondary BIOS chip, whichever one that may be, test the new BIOS out, go, it sucks or it's great, and then, you know, like if it's great, you can just continue using it and leave the other one unupdated, right? There's nothing stopping you from doing that. And if it sucks, well, you can go back to the good previous one that's good, right? So that's kind of the other sort of more normal use for dual BIOS. The other benefit of it is also if you have like corrupted BIOSes, then you can recover from that as well using the dual BIOS functionality. Next to that, we get a bunch of voltage read points. This is a stupid location to put voltage read points. There is a postcode. Unfortunately, it plugs into, like, it's not built directly into the board. It's integrated into the cover of the board again. And, oh yeah, down here you get an extra 6-pin power connector, because if you do decide to run, you know, a completely irrelevant quad SLI, quad crossfire setup that no longer is supported by anything but benchmarks, you're gonna, like, the thing is, the GPUs can quite easily overload, quad GPU setups can quite easily overload 24-pin power connectors. So this connector is down here to actually power the PCIe slots, because this only has two 12-volt connections, whereas this has 3. So obviously this can provide more power, and I do believe they're actually run in parallel, so yeah, it really takes off a lot of load from the 24-pin. So that's you know, so you basically only use this if you're running like 3 or 4 cards. This is arguably the main reason why this thing is XL-ATX is the VRM itself, because as you can clearly see, it's massive. It's so massive that they had to shift all of the memory slots down just so that they could get it on the board. And what is it? Well, this is the VCore. Yep, this is all just VCore, and it's a 16-phase. And a very, very real 16-phase. No doublers, no power stages in parallel, just straight up 16 phases, because Threadripper 3 is, of course, compatible with the XDPE 132 G5C, and the 132 G5C is epic because it can support 16 phases, and here it's running as a 16+0, so if we look at the back of the board, we see no doublers, because there aren't any doublers, because what was it, XDP 132 G5C is just that freaking awesome. So yeah, just true 16 phase setup, and yeah, I don't think technically this might not be the first. Well, the thing is, Gigabyte has, no, this might actually, yeah, it is this first. It is the first 16 phase, because the X570 Xtreme is a 14+2, and the X299 boards don't support the XDPE 132 G5C. So this is actually the first motherboard where you just have a straight up 16 phase VRM from the controller. And so basically this means that, you know, like, depending on the firmware configuration, this and the output filtering capacitor configuration, the transient response of a VRM like this can be absolutely incredible. And I say depending on the firmware and the capacitor configuration, because it really depends on those a lot as well. Which is kind of like, so physically everything necessary to get great transient responses here. How it actually performs, you'd have to check with a real, like you'd have to measure with an oscilloscope. But inherently, this design should deliver absolutely incredible performance just in all metrics, including power efficiency and power handling capability, because all of these power stages right here are, of course, TDA 21472s, because well, it's a flagship motherboard. It's got to have flagship power stages. Though International Rectifier, well, Infineon, it's Infineon and International Rectifier. The funny thing is, I do believe, like, this right here is an IR logo. Like, these couple pixels right here, yeah, that's an International Rectifier logo, but IR is now owned by Infineon, so it's kind of like, well, it's an IR branded part made by Infineon, so what do you call it? Right? So anyway, these are basically the best power stages. Like IR, they do make a 21475, which I think is still, I do believe, 70 amps, but with a better, like a thermally enhanced package where it basically has a metal tab instead of just the standard, I can't remember what power stage packages are made of right now, so we'll just not get into it. But yeah, they'd have like a metal package instead of whatever it is that it normally is. Yeah, so these are 70 amp smart power stages, and smart power stages are smart because unlike regular power stages, which it's like for power stages, there's a bunch of optional features like current monitoring, temperature monitoring, and then various protections. Yeah, smart power stages require a very accurate current monitoring system, temperature monitoring, over temperature protection, over current protection, and a whole bunch of other protections that are just so, like, I don't care about listing off because I don't find them interesting. But that's what makes these smart, because they integrate a whole bunch of functionality that otherwise you'd have to implement either from like the controller or maybe even with extra circuitry on the motherboard, which just nobody like. Well, the thing is, these are really meant to be used in server applications, so it's just like integrating more stuff into the actual power stage for server applications where the boards are kind of just built to a spec, so it's just like minimize the number of things that can get customized by the manufacturer is kind of the way to go there. So yeah, but so that's kind of what makes the smart power stages smart, is just they integrate a whole bunch of features that a bare minimum power stage wouldn't have because they're not really necessary. So they're also ridiculously efficient, which is how they get that 70 amp rating. So well, the thing is, I don't know what voltages will be viable for overclocking Threadripper 3, because, I mean, here's the thing. If you run the 32 core, theoretically, if you run the 32 core at 1.3 volts on the SVI2 TFN sensor, it's going to be pulling, in Prime 95 small FFTs, it's going to be pulling like 100, it should pull 100 amps for every 8 cores, so the 32 core should be pulling like 400 amps. Which is kind of insane and may very well not be coolable, just like your water cooling system is just not going to be able to handle it. And yes, water cooling system would at that point be definitely required. So because of that consideration, you might not actually end up at that voltage. But the thing is, I don't actually care that much about what voltage you're going to run this at, because the datasheet is spec'd at 1.2 volts. So that's what I'm speccing all of the parts at. And the current draws, I've just kind of taken educated guesses. So 1.2 volts output, 400 kilohertz switching frequency, and 5 volts drive, because that's literally the only voltage these parts run on. Though it is worth noting the 64, like if the 64 core ends up on this platform, this VRM right here might actually meet its match, because as it is, you know, we've got 16 phases of these lovely power stages, and these hit peak efficiency at 20 amps output, which is 320 amps coming out of the VRM. Like, you're like, this is not going to hit peak efficiency at stock settings. Like, you can be assured of that. It'll probably have to turn off a few phases if you want peak efficiency at stock. So that's kind of the thing. Anyway, so for the following current outputs, you're looking at the following efficiencies. 200 amps, it's going to produce about 16 watts of heat. 320 amps, which is that peak efficiency point. I normally only have, well, I guess I just did it because peak efficiency. It's going to produce about 25 watts of heat. 400 amps, which is like where this is probably the theoretical limit of what you can push into the CPUs, just also because going much past 1.3 volts is not safe for the longevity of 7 nanometer AMD CPUs in all core workloads. There's kind of a lot of conditions with that because how much voltage and how much current is safe is conditional. You know, if you're pushing, well, the thing is how much voltage is safe is depending on how much current you're pulling, and how much current you're pulling depends on how much, you know, how heavily loaded the CPU is and how hot it's running. And so it's kind of like, you know, if you stay below 1.325 volts, you're not really going to get past 400 amps. So this is probably like, this is the theoretical upper limit if you're just voltage limited and not like thermally limited. Because if you're thermally limited, it could be a lot less current that you'd end up at, right? You could end up in this range. So anyway, 400 amps output, this VRM will produce only 32 watts of heat, which is nothing. Like that is, for this much current, that is nothing. And then outputting 600 amps. So at this point, we're going like extreme overclocking. The VRM would produce 59 watts of heat. And this is a significant amount of heat, but the thing to keep in mind is if you're doing LN2 overclocking, your benchmarks, especially say Cinebench on like a 32 core Threadripper, is going to last a couple seconds. That VRM ain't gonna even, like, that VRM's not gonna have enough time to overheat in 30 seconds, right? So that's something to keep in mind as well, is like the heat output also is relative, like how much you need to worry about cooling the VRM is also dependent on how long do you plan to run it at that much load for. So yeah, that's kind of the thing to keep in mind. And so 600 amps, you know, for any kind of extreme overclocking application, this is totally acceptable. And then going up to 800 amps, which is like, if the 64 core ends up in being on this socket, and it isn't thermally limited, which would make it a 1000 watt CPU, which is just like, well, good luck with the water block for that. And then like the radiators for all of that. Because here's the thing, a 360 millimeter radiator at like 1800 RPM fans is good for roughly 400 to 500 watts of heat dissipation, depending on how thick it is. Yeah, with this, and that's assuming you want like 10-degree water delta. If you let the water hit 20 degrees above ambient, which would make the water, let's say you're in a 20-degree room, the water would be 40 degrees, your CPU would be absolutely roasting, so yeah, you're not going to do that. Basically, you'd need like at least 640 millimeters of radiator for 1000 watts of CPU. That's assuming that the water block doesn't end up being the bottleneck, or the IHS could end up being the bottleneck, like the soldering could end up being the bottleneck, right? In terms of cooling the CPU, and it's just like, yeah, well, if the 64 core isn't thermally limited, this is theoretically where it could land. And that's kind of where it's like, okay, maybe the water cooling the VRM on this thing would be a good idea at that point. But I really wonder, like, if they're actually, like, releasing a 64 core, I think it would be thermally limited. I think you just wouldn't be able to cool it before the VRM became a problem. Because, like the thing is, it's just like 64 cores, overclockable is just completely insane from just kind of a power perspective if you don't run into cooling issues first, right? Because if you run into cooling issues at 500 watts, then it's just like, well, the VRM's fine with that. It's completely cool with that. It's not cool with this. So yeah, and the 64, the thing is, AMD might decide to put the 64 core on a different socket, which in my opinion, from a power delivery's perspective, would be a good idea, because I'd say it needs motherboards built to the same standard like the LGA 3647 boards are built to, right? Where you basically have 32-phase VRMs, at least the Gigabyte one's a 32-phase, and the ASUS one is like this giant 8-phase with 4 70-amp power stages per phase, which effectively puts it, like, it has 32 power stages, right? Which is like twice the size of the VRM is like twice the size of this one. Because, yeah, like, the thing is like 400 amps, it's happy, right? So if you just double the size of the VRM, it'll stay happy for the 800 amp output. So yeah, anyway, for at least for the CPUs that we know for sure are going into this socket, this VRM is plenty. It's not really overkill because, you know, to get really overkill, we'd need to, like, I'd say for this to be really overkill, you'd have to be significantly, like, you'd have to be at the point where at full load, you'd have to still not have the entire VRM running in terms of active phases. This kind of, like, at this point, you need all the phases. And from that point onwards, you just need all the phases. So this is just like, yeah, this is a good fit. Finally, we have a CPU worthy of a 16 phase, right? And then maybe we'll find out that it's completely uncoolable and it's just like the VRM gets to chill anyway. But yeah, so that's the VCore VRM, and it's great. It's an absolutely epic VCore VRM right there. In terms of the SOC power delivery, so this powers the I/O die. We got this VRM down here. It's just 3 phases. It's controlled by this chip over here, which that is an IR35201. No, I keep saying that. 35204, running in 3+0 phase mode. And that's got just more TDA21472s. Here's the thing. So outputting 60 amps to the CPU at 1.2 volts, which is more SOC voltage than you'd be actually running, because really you don't want to run the SOC voltage above like 1.1 volts most of the time. But let's say you did run 1.2 volts. Again, well, same basically output, like operating parameters for the VRM as here. You'd be looking at less than 6 watts of heat. Well, depending on the thing is, this needs a heatsink right here. This runs pretty hot, and there's kind of a lot of power delivery because this is like your memory VRM over here. So this probably should have a heatsink, but it could also be perfectly capable of cooling itself. The other thing is, I'm not sure that the I/O die will pull 60 amps. That's kind of the high. Actually, that's really high for just the I/O die. I'd expect the I/O die to land somewhere under 40, even if you're really pushing like high memory clocks and well, I guess it also depends on how many PCIe devices you're running at the same time. But yeah, I wouldn't expect the I/O die to get anywhere near 60 amps output, especially because there's boards with two-phase VRMs for the I/O die. So yeah, like it's not going to pull anywhere near 60 amps, but if it did, this VRM would still have no problem dealing with it. So that's plentifully, like, this is overkill, right? This is adequately sized for the job. Overkill. Because honestly, you're going to be below the peak like the peak efficiency of this VRM under all should be under peak efficiency under all operating conditions. Anyway, so that's the that's the SOC VRM. It's called SOC, but it powers the I/O die, because the I/O die used to, well, back when the I/O die wasn't a thing, everything that wasn't a core was the system on a chip. So the name for that VRM stays from that, because it just powers everything that isn't a core. So anyway, moving on from that, and yeah, let's just move on from that, because there's no, you know what's kind of funny? There's X570 motherboards with like 4-phase SOC VRMs. Just saying. Also, I've not noticed any advantage to them having 4 phases for the SOC, but they exist. So just kind of like, yeah, that's the thing. Now let's move on to the VRM I find the least interesting, which is the memory VRM. And that's these two that's these two right here. And both of these are single phase, controlled by this chip right here. That's some single phase rich tech controller. I think it's an RT, like, unless Gigabyte changed parts recently, that should be an RT8120. And that's a single phase. And the MOSFETs in this, you have a high side, low side, and another low side. All of the MOSFETs are 4C06Ns. These are MOSFETs that unfortunately find their way into a lot, tend to be popular as low side MOSFETs for low cost VRMs. Here they're for everything, because this runs off of 5 volts, so you can have a slower high side MOSFET because it handles more of the current. But the thing is, I usually complain about these because they somehow find their way into like VCore power delivery, where they have no place because they're not great and not very efficient. But VDDR is a rail that really doesn't need to push much in the way of current, which is why Gigabyte has been copy-pasting this memory power delivery system since like Z270. And I'm serious about that. Like, this is a VRM you'd see on even like Z270 Gigabyte boards, and they keep using it because it works just fine. So yeah, that's why you have it here as well. And unfortunately, we cannot see the memory topology because it looks like, oh my god. Is that PCIe? Oh, it is. Oh man. That must be an absolute nightmare in terms of, well, there's a reason why this has an 8-layer PCB. So that's kind of, yep. Yeah, that explains a lot. I did not realize that was going on until just now. Unfortunately, we can't see any of the memory layout, but as far as I know, this should be a daisy chain memory topology. And so basically what that means is the motherboard will prefer, if you're trying to push like high memory clocks, it will prefer having only these 4 DIMMs occupied. But the thing is, Ryzen's 3rd gen, well, I'm not sure if the Threadripper 3 memory controller behaves the same way, but I would assume it does, because it should be the same thing. The Ryzen 3 memory control, like the thing about daisy chain boards is that they generally kind of have a disadvantage if you run all your DIMM slots populated, but with the 3rd gen memory, like the Ryzen 3rd gen memory controller, actually, like there is a hit in terms of overclocking range. It's just not big enough to push you below the 3800 megahertz threshold. So it's just like, it doesn't matter, because most people's FCLK can't run 19900 megahertz stable anyway. And for peak memory performance on Threadrippers, well, maybe Threadripper works differently. I really doubt it does. But assuming Threadripper 3 works like Ryzen 3rd gen does, if you can hit 3800 megahertz on 4 DIMMs, which daisy chain can do with the Ryzen 3rd gen memory controller, there's no point. Like, there's no point to having a T topology, because there's no point for the higher frequencies at all, because you get peak performance when your FCLK and your memory clock are matched, and the highest FCLK you're going to run is 1900, which matches up to 3800 megahertz. Well, I should be saying mega transfers on the memory. So that's kind of the thing, is just like, there's like, you know, T topology would maybe help you with going 4000 megahertz plus on 8 DIMMs of memory. It's just that there's absolutely no point doing that with the Ryzen 3rd gen memory controller, which I assume is exactly the same on Threadripper 3. So yeah, the daisy chain topology would not actually lead to any disadvantages. Whereas the, and it only really gives, like, it doesn't give you any practical disadvantages, and it does give you an advantage in that if you are only running 4 DIMMs, you can push some silly frequencies for, you know, screenshot purposes, because again, they're not actually going to give you any useful performance. So yeah, and I think that covers everything. We've gone over the memory layout, we've gone over the memory. We've gone over the power delivery for the memory, the SOC, the VCore, the, you know, the fact that this board has dual 10 gigabit Intel LAN. All of the buttons that should be in the rear I/O are in the rear I/O. The only thing that's really dumb is the voltage read points. So yeah, this is the TRX40 Aorus Xtreme from Gigabyte. Honestly, it's kind of the perfect motherboard in my eyes. You've got a massive 16-phase VRM. There's nothing, in my opinion, to complain about in the... Well, I guess some people might want Thunderbolt 3 support, but personally, I don't. So, yeah, as far as I'm concerned, the I/O section's perfect. You know, you got dual BIOS, you got BIOS switches, you got spacing for quad fire, because I am one of those people that thinks Time Spy, and, well, 3D Mark in general is just the best game ever. And yeah, it's just like, from, like, there's nothing I can find to really complain about on this motherboard, because it's just absolutely great. So yeah, that's the TRX40, TRX40 Aorus Xtreme. Very deserving of the Xtreme name as far as I'm concerned, because it is very extreme. Well, I think the VRM could have been more extreme, but like, at this point, it really wouldn't fit on the board. Like, it's already huge. So yeah, that's it for the video. Thanks for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment sections below. And if you'd like to support Gamers Nexus, we do have a Patreon. There's a link to that down in the description below. And there's also the Gamers Nexus store at store.gamersnexus.net. And there's shirts, mugs, mod mats. I'm trying to remember the various merch we have, the various merch that's there. Anyway, Steve might just edit that out. So anyway, that's it for the video. Thanks for watching, and goodbye.